Hello friends, today I'm going to work on one problem which was posted on Facebook in some forum. So the problem is, like as you can see in the diagram, I'm not going to touch the first and second one, but I'm going to work on the third one, as it is a bit difficult and more important from the perspective that it involves both geometry and time distance concepts. So basically for that, let me just draw one diagram first so that it becomes quite easy for you to understand. So the problem statement goes like this: two cars starts from one point and move along two roads at right angles to each other. So basically one car starts from here, from the origin. Let's say this is my origin. One car starts from here, point O, and that car moves along y direction, and another one moves along x direction. Their speeds are 36 km per hour. Let's say the one moving towards right side has the speed 36 km per hour, and the one moving upwards has 48 km per hour. After 15 seconds, the distance between them will be. That's interesting problem. So let's say after 15 seconds, this car reached up to some point here. Let's say this point is y, and another one moved here, reached here. Let's say this point is x. So we have to find this distance between them. So first of all, like this is a 90-degree angle, right? Both are moving at 90 degree to each other. So this angle is 90 degree. So that means we have to find the length of the hypotenuse. If you remember the Pythagoras theorem, so let's say this is P, this is B, so we have to find the length of this. So one thing is for sure, we can apply the Pythagoras theorem, according to which hypotenuse is equal to square root of perpendicular square plus B square. Let's keep this concept aside. Now to get the value of h, we need to know the value of P and B. So P is this distance and B is this distance. So let's find the distance moved by each car. So P is basically speed, which is, we have to specially take care of the units here, otherwise we can make mistake. So P is 48 km per hour speed multiplied by distance. What is distance? Oh sorry, a time, 15 seconds. So the speed is given in hours and distance in kilometer, and the time is in second. And just check the options, the answers are given in meters. So what can we do here? Let's convert hours into seconds. So 1 hour has how many seconds? This you can remember. 1 hour has 60 minutes and each minute has 60 seconds. So 60 into 60, 3600 seconds. An hour has 3600 seconds. So perpendicular P will be 48, and if I need to convert kilometers into meters, so 1 kilometer has 1000 meters. So 48 into 1000 meters divided by 3600. So then the units will get converted from kilometer per hour to meter per second, multiplied by 15 seconds. We convert it to second because the time is given in seconds, and the answer is given in meters, so we converted kilometer to meters. So this will cancel out, 2 zeros. So we can cancel out 36, 12 3 is 36, 12 4 is 48. So P will be, and this 3 will cancel out this 15 also, 5. So 5 4s are 20. This second will also get cancelled out. 5 4s are 20, and so 1 0 from here. So it is 200 meters. Similarly, if we do the calculations for base as well, so base will be, if without doing all this, like how can we quickly do it? Now we have learned that to convert kilometer per hour to meter per second, we just need to put this fraction here, 1000 by 3600, and the units will change to meter per second, right? And we have to multiply with 15 seconds, right? So this 36 cancels out, zeros cancel out, so B will be 150 meters. So we know P and we know B, so what will be H? We have to put them in this formula, right? So just looking at the options, what can be the answer? Probably maybe somewhere around, like if let's say so now how are we going to solve it quickly without actually performing all the calculations? The key is that, let's say if our P is 2, let's just scale down the values of P and B from 200 to 2, so it will be 2 square plus, let's say B is around, B is also B is 1.5 square, so let's make it 2 only for now. So it will be, but for under root 8, somewhere even lesser than under root 8 basically. So and under root 8 is even lesser than under root 9, right? So under root 9 is 3, so the answer will be less than 300, right? You are getting my point? The answer will be less than 300. So but it will be definitely more than 200, right? Because this distance is always going to be less than this distance, so it will be more than 200 but less than 300. So what's that option? The option D, 250. Okay, let's just cross check it as well, like you can stop calculations here and you're done with GMAT answer, right? But let's just, for the sake of checking, let's check it. I can use the calculator here, right? But you are not going to use it in exam, so let me just, 2 square is 4, so what will be 1.5 multiplied by 1.5, 2.25, right? So plus 4, right? Now the square root, let's take the square root, so it will be 2.5, right? So our logic was correct without solving these big numbers, 200 and 150. There are ways to solve it as well. We can take 100 outside as well, and we can simplify it, but just by this logic here, that it will be less than under root 8, and it will be, which is less than under root 9, so it will be less than 3, so we have only one option, 250, right? Because it will be anyway more than 200. So that's how you have to think about solving problems, how you can solve the problems by checking the options and using some logic. The more you practice, the more you look at the diagrams, the more you think about it, you are going to get more ideas on how you can solve the problems quickly, right? It comes with practice. You should practice tons of problems. Thank you for watching the video. Let's continue.